Hey everyone, welcome back to a new module. This module is about cloud computing. So in this module, we'll learn about the concepts of cloud computing, what is container. I'll explain the serverless computing concepts, then what are the cloud computing threats and methodology, and about the in the end we'll go with cloud security. So this is our module flow or learning objective from this module.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
So if I talk about cloud computing, so this is the intro of cloud computing. So cloud computing is an on-demand delivery of IT capabilities where an IT infrastructures applications are provided to the subscriber as meter service over the internet. So let's say you are having an application for calculator, and this is some different kind of calculator which is not present over the market. So you will allow your calculator to run over internet, our application over the cloud, and you will sell these services in the meter based connection. So you will sell this services, for example, $24 a month. So like this is somewhat we can say a subscriber based connection. You will not properly sell your application. This is just a subscriber based services. So what are the characteristics of clouds? So if I talk about characteristics, number first is the on demand self service. So like you can demand the services when you want. It is available 24/7. Distributed storage. So storage that is needed in your storage device, that is your computer, is less as compared to where the main application is stored. Normally this would run on cloud, so it doesn't need any storage, just a cookie storage that is in the KB part. So that's not a big deal. Then rapid elasticity, automated management, broad network access, resource pooling. These are the characteristics of cloud computing. Measured services, and virtualization technology. So these are some good characteristics of cloud computing, or you can say these are just the cloud computing characteristics. Now we have different types of cloud services. So types of cloud services or cloud computing services. So let's start from IaaS, PaaS, SaaS, IDaaS, SEC, as and CAS, FAS, and XS. So now we'll start from the first point of view, that is IaaS. So IaaS, it is infrastructure as a service. So it provides virtual machines and the abstract hardwares and operating system which may be controlled through a service API. So for example, Microsoft OneDrive, Rackspace, Amazon EC2. So those are the like infrastructure as a service. Infrastructure as a service. Second, we have PaaS, that is platform as a service. So platform as a service here it offered the development tools, configuration management, and you can say development platforms on demand that can be used by subscriber to develop custom applications. For example, like Google App Engine, Salesforce, Microsoft Azure, and we have SaaS. SaaS is software as a service. So software as a service it offers software to subscribers on demand over the internet. Example, web-based office applications like Google Docs, calendars, Salesforce, CRM, and FreshBooks. So those are the software as a service. Then we have IDaaS. So IDaaS is entity as a service. Identity as a service. So it offered the IAM services including SSO, MFA, IGA, intelligence collection. So for example, like one login, certified entity services, Microsoft Azure Active Directory, or Okta. This is for the system administrations. Then we have SecS. So Sec you can just guess it is security. So security as a service. So security as a service, it provides the penetration testing, authentications, intrusion detections, anti-malware, security incident, and event management services. So like these are the SIEM tools which is provided over the cloud to run your systems and protect your systems. Then there is CAS. So CAS is container as a service. So it offered the virtualizations of container engines and management of container applications clusters through web portal or API. So here again you can go with the example of Amazon EC2, Google Kubernetes engines. So like if I talk about virtualizations and containers, so virtualization is bare metal machines. So those are the operating systems and all. A container is a piece of application that you want to run. You don't have to go with like full bare metal operating system over here. Then we have FAS. So FAS is function as a service. So it provides platform for developing, running, managing application functionalities for microservices. And then access. So access is anything as a service. So it offer anything as a service over the internet based on the user demand like digital project, food, transportations, medical consultation, etc. So this is the like services which is provided. Now let me download the image for you for the better understandings of responsibilities. Separation of responsibilities. So this is like separations of responsibilities. So these are the main cloud computing services, platform infrastructures and softwares. So on premises you can say this color that is blue color that is highlighted in blue color, the boxes that you have to manage, and the gray color is the like managed by the cloud provider. So If I talk about the on-premises, that is, you have to manage all things. Infrastructures, you have to manage like application data, runtime, middleware, OS, and virtualization, servers, storage, networking will be offered by the cloud computing. Platform, you just have to manage application and data. Rest, runtime, middleware, operating system, virtualization, server, storage, and networking are managed by the cloud. Software as a service, so everything will be managed by the cloud provider, service provider. Now, we'll talk about the cloud deployment method or models. So we have public cloud, private cloud. So till now we can understand the clouds are providing services. Community cloud, hybrid cloud, and multi-cloud. So if I talk about one by one, so if I talk about public cloud, so here services are rendered over a network that is open for public use. The private cloud, here cloud infrastructure is operated for a single organization only. About the community cloud, here the shared infrastructure between server organization for a specific community with common concerns like security, compliance, or jurisdictions, anything. About the hybrid cloud, here it is combination of two or more cloud, that is a private, community, or public, that remain unique entities but are bound together, thereby it is offering the benefits of multiple deployment models. Then if you have multi-cloud, so multi-clouds are dynamic heterogeneous environment that combine workload across multiple cloud vendors managed via one proprietary interface to achieve long-term business goals. Now, the most important thing, that is the NIST Cloud Deployment Reference Architecture. So, if I talk about NIST Cloud Computing Reference Architecture, it has cloud consumer, cloud provider, cloud carrier, auditor, and broker. So, consumer are a person or person organization that uses the cloud computing services. The provider is the person organization that is providing the services to the interested parties. The carrier, so it is an intermediary for providing connectivity and transport services between cloud consumer and providers. Cloud auditors, so cloud auditors are a party for making independent assessment of cloud service control and taking an opinion. Then we have cloud broker. So cloud brokers is an entity that manage cloud services in terms of use, performance, and delivery, and maintain the relationship between cloud providers and consumers. That is the architectures for the reference. Now, like just how I talk about the major five major actors. So this everything that is inside the architecture. These are the major actors that is performing the role in the NIST. Now there is one more thing that is important nowadays. So nowadays AI is playing the role in cloud computing. So by integrating the AI with the cloud, organization can efficiently manage data on their own, build and train system to search for patterns and gain actionable business insight, and enhance the consumer or customer experience and optimize their workflows. Now we'll talk about what is fog computing. So, fog computing is a distributed and independent digital environment in which applications and data storage are positions between data, resources, and a cloud services. So, cloud fog computing is distributed and independent digital environment. It acts as an intermediary between the hardware and remote servers, and also called as an intelligent gateway. So, it is used for enhanced data processing, storage analysis in a quick and efficient manner. The main thing that is highlighted over here is it's distributed, independent, digital environment, intelligent gateway, and enhance data processing. If I talk about the edge computing now, so edge computing is a distributed decentralized computing model in which data processing is performed close to edge devices. So it helps in building automation systems that perform the fast processing and enable efficient real-time applications. So now like there are the different like cloud service provider, that is AWS, Microsoft Azure, IBM, Google is also there. So this is the first part where we will summarize the cloud computing concepts.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
So let's talk about what is container technology. So if I talk about container, so container is a package of application and software, including all its dispensed like dependencies such as libraries, files, configuration files, binaries, and other resources. And CAS, container service, is a service that include the virtualization of containers and container management through orchestras. So using CAS, subscriber can develop rich, stable, containerized application through the cloud on-site data centers. If I talk about container versus virtual machine, so virtual machine or virtualization is the ability to run an operating system on a single physical system and share the underlying resources such as server, storage, device, or network. Container are placed on top of physical server and hosting system and share the operating system kernel binaries and libraries, thereby reducing the need of reproducing the operating system. So containers are lightweight. So for example, if I want to run a tool, I don't require to install a virtual system for it. I can use container. So container are lightweight and and basically less heavy than we have Docker. So Docker is an open source technology used for developing, packaging, and running application and all its dependencies in the form of containers. So in the form of container to ensure the application work on seamless environment. And basically Dockers provide a platform as a service through OS level virtualizations and deliver containerized software packages. Now, Docker networking, if I talk about, so Docker connect multiple containers and services or other non-Docker workloads together. And Docker networking architecture is a set of interface known as Container Network Model or CNM. Container Network Model. So Docker native network drivers include host, bridge, overLAN, MAC, VLAN, and none. If I talk about what is Kubernetes, so Kubernetes is also known as K8s. So it is an open source portable extensible orchestration platform developed by Google for managing containerized application. Managing containerized application. So Kubernetes provides a resilient framework for managing distributed containers, generating deployment patterns, and performing failover and redundancy for the application. So Kubernetes has features such as service discovery, load balancing, storage orchestration, automated rollouts and rollbacks, automatic bin packaging, self-healing, security, and configuration management. So if I talk about container like Docker versus Kubernetes, so Docker is an open source software that can be installed on any host to build, deploy, and run containerized application on a single operating system. So when the Docker is installed on multiple hosts with different operating system, you can use Kubernetes to manage this Docker host. And Kubernetes is a container orchestration platform that automate the process of creating, managing, updating, scaling, and destroying containers. So that those are the different things: container, Docker, Kubernetes, virtualizations machine or virtual machines, and containers having some security challenges such as large surface attack. Large surface attack, like it has large surface to attack, so like large attack surface you can say. Lack of visibility, and bypassing isolation, and they are like network based attack for this noisy neighbor containers. Containers break out to the host, and ecosystem complexity, DevOps speed. Those are the um, problems. And containers management platforms, if I talk about, so we have Amazon ECS. You can manage through this. You can manage it from the Docker. You can manage it from the Red Hat OpenShift container platform. For Kubernetes platform, you can also use Amazon EKS, Amazon Elastic's Kubernetes service, Knative DKS. Now, if I talk about serverless computing, so the serverless computing is also known as serverless architecture or function as a service. And it is a cloud-based application architecture where application infrastructure and supporting services are provided by the cloud vendor as they are needed. So serverless computing simplifies the process of application deployment and eliminates the need of managing the server and hardware by developers. If I talk about server versus containers, so containers, the developer is responsible for defining container configuration files along with the operating system, software's library, storage, and networking. In the serverless computing, the developer only need to develop and upload code to support and serverless computing. The entire provisioning processes is taken care by the cloud service provider. So that is about the serverless computing. You can use Amazon Azure for the serverless computing. Now we'll talk about what are the cloud security threats or the threats in cloud computing. So number one threat is accountability and data ownership. Accountability and data ownership. So using public cloud for hosting businesses services can cause several risk for recoverability of data, user identity federation. So creating multiple user identities for different cloud provider make it complex to manage multiple user IDs and credentials. These are the OAP's top 10. Then we have regulatory compliance. Regulatory compliance. So the regulatory compliance is basically this is the lack of transparency, and there are different regulatory laws in different countries. Then we have business continuity and resiliency. So here there can be a business risk or monetary loss if the cloud provider handle the business continuity improperly. Then there are user privacy and secondary users of data. So the default share feature in social web site can jeopardize the privacy of user personal data. And services and data integration. So unsecured data in transit is susceptible to eavesdropping and interception attacks. Then the multi tenancy and physical security. So poor logical um, segregation may lead to tenants with security features of other tenants. Incidence analysis and forensic support. So due to distribution storage of log across the cloud, law enforcement agency may face problem in forensic recovery. Then there is infrastructure security. Misconfiguration of infrastructure may allow the network scanning for vulnerable application and services. Then non-production environment exposure. The non-production environment increase the risk of unauthorized access, information disclosure, and information modification. So these are for the cloud. Then the serverless security risk is simple that we have the top 10, that is injection, broken authentication, sensitive data exposure, XSE, broken access control, cross-site scripting, and all. Those are the threats. And if I talk about like cloud computing threats, so we have the data breach for that or loss. So data loss include like data when data is erased, encryption keys are lost, illegal access to the data, misuse of data. That is about the threats, and like insecure interfaces and APIs is also a threat for cloud computing. So that is about the cloud computing threats. If I talk about like threats more, so that is we can say privilege escalation is also a threat. Natural disaster, so like if your server is um not working due to like there's a flood at your area, and the hardware failures, supply chain failures. Those are the threats and common threats that people used to face. Or you can say authentication attack, network management failures, poor networking, or cloud provider execution, management interface compromise. Those are like some of the threats. And one of the major threats for the cloud computing is licensing risk. The organization may incur a huge licensing fee if the software deployed in the cloud is charged on per instance basis. So people have different like threats which are going on, and people have different threats for Kubernetes. Then there's different threats for containers. So containers, if I talk about unauthorized access, hijack images, registries, exposed services due to open port, exploited application, embedded malwares. Those are the for the containers. If I talk about Kubernetes, so there is no certification revocation, hard-coded credentials path, no backup processes for scheduling, non non repudiation. Those are for the like threats for the Kubernetes. Now, I want to talk about one attack type, that is side channel attack or cross guest VM breaches. Side channel attack. So this is a cloud attack. So here the attacker compromised the cloud by placing a malicious virtual machine near the target cloud server and then launches a side channel attack. So in side channel attack, the attacker ran a virtual machine on the same physical host as the victim virtual machine and take advantage of shared physical resources and steal data from the victim. So side channel attack can be implemented by co-resident user. If I talk about wrapping attack, so wrapping attack is performed during the translation of SOAP messages in the TLS layer, where attacker duplicate the body of a message and send it to the server as a legitimate user. Then there is the man in the cloud attack. Here, like it is advanced version of man in the middle attack. So here attacker use an exploit that intercept and manipulate the communication between two parties, while many in the cloud attacks are performed by abusing cloud file synchronization services such as Google Drive, Dropbox for data compromise, command and control, data exfiltration, and remote access. There's one more attack, that is Cloud Hooper attack. Cloud Hooper attack. So Cloud Hooper attack are triggered at the managed service providers (MSP) and their users. So attacker initiates spear phishing emails with custom-made malware to compromise the account of staffs or cloud services firm to obtain confidential information. Then there is a cloud-borne attack. So the cloud-borne attack is very famous. So it is a vulnerability that is residing in bare metal cloud servers. Bare metal is the whole architecture of cloud. If I talk about bare metal, so our Kali right now is the virtual machine one, but if you go with the bare metal, so it is a whole operating system that required a whole new architecture, and it is heavy. So the malicious backdoor can allow the attacker to bypass security mechanisms and perform various activities such as watching new user activity behavior, disabling the application or server. So the cloud-borne vulnerability is already residing in the bare metal cloud server that enable attacker to implant a malicious backdoor in its firmware. Those are the threats. So if I talk about what is cloud hacking methodology, so what is cloud hacking? So cloud hacking attacker here exploit the vulnerability existing in the cloud technology to perform various targeted high-profile attack on cloud storage system, compromising the corporate and customer data. So the main objective here of the cloud hacking is to gaining access to the user data and blocking access to the cloud services. So for the for scanning the vulnerability, people use this tool Trivy, and for scanning Kubernetes vulnerability, Kubernetes. So people use the tool sysdig for cloud. So there is a simple storage service, that is S3. So SSS, simple storage and service, so it is known as S3. So S3 bucket. So S3 is a scalable cloud storage service used by Amazon, where files, folders, and objects are stored via web APIs. Attacker often try to find the bucket location and name to test its security and identify the vulnerabilities in the bucket implementation. So let's do this example. Still my lab is opening up. I'll talk about the next topic. So if I want to enumerate the S3 bucket, I will do this reverse IP search. I will use Google Advanced Hacking, and now we'll use a tool for the S3. The tool name is S3 Scanner. So attacker use S3 Scanner to identify open S3 buckets of cloud services such as Amazon, AWS, and retrieve their content for some malicious purposes. People used to enumerate IAM roles. So and attackers enumerate IAM rules by analyzing the AWS error messages, which reveal information regarding the existence of a user. So we can also use this 3 interceptor, and people used to enumerate Azure Active Directory account. So with the help of like a tool which is Azucar, and we'll do the like S3 bucket enumeration right now. So exploiting and misconfigured AWS bucket. So first of all, you have to identify the S3 bucket, then set up the AWS command line interface, extract access key, and configure AWS CLI, identify vulnerable S3 buckets, exploit the S3 bucket. So like those are the methodology for exploiting the AWS or S3 bucket. Now if I talk about like serverless based attacks on AWS. So like first of all there are two approaches, black box and white box. So again you have to go with the attack mechanisms over there. And yeah, exploiting Docker. So you can exploit the Docker also via the remote API. For that you have to find the API that is like retrieving file from the Docker host is docker dash h remote IP and port, then pull alpine. So this is for like get the image of alpine Linux. So you can do pretty much thing if you find open Docker, and if you're able to retrieve information. You can use the cloud go to, it is a vulnerable by design AWS deployment tools. So CloudGuard is a Rhino Security Labs vulnerable by design, the name of AWS deployment tool. So this is it allow you to hone your cloud security skills by creating and completing server capture the flag style scenario. So you can try this cloud go to for testing your skills. So mechanism is same. Here we are going to enumerate the web security part. So you can also like create a backdoor account in ABS. So also you can have the backdoor installed in Docker, Kubernetes and cloud. That is the hacking mechanisms. So for the AWS hacking tool, you can use the AWS PWN pawn. So AWS pawn is a AWS hacking tool that include various automated scripts for hacking phases such as reconnaissance, escalating privileges, maintaining access, and clearing track. Now we'll do the practical of a S3 bucket. Let's launch the lab. So for this, we are going to use a tool S3 scanner. Let's get into the system. Let's open the terminal. Let's go with sudo su. You can install this tool in your system also. Right now, what I will do is like I'll find the S3 scanner. So it's inside the cd slash home tracker S3. So here there is a file for requirements. Let me find that. So right now in the okay, here is the requirement.txt. So we'll install the required files. Pipt install -r requirements.txt. So it will like install the required libraries for our tool. Now I'll run the tool. So Python, let me clear it. Python 3 dot slash s3. Okay, here is the file. Now this file contains these sites. Let me open the file over here. So whenever you install this tool, you have to create a directory for this, and here the sites.txt contain the sites, different sites. So let's find that. So you can paste like the site that you want, and you can search for a list. Sites.txt. Let's run this. So you can see that we have found the S3 buckets and this particular sites. Exploiting part, you have to find the you have to configure the AWS CLI, and then you have to exploit that. So for that you need the AWS accounts, and then you have to go with the exploitation part. Now, if I talk about the cloud security, so cloud security has some control layers. So if I talk about cloud security control layer, so let's start with application. So start with application information management network, trusted computing, computation storage, and physical. So these are the control layers of cloud security. And if I talk about cloud security considerations, so cloud computing services should be tailor-made by the vendor as per the given security requirements of the client. Service provider should provide higher multi-tenancy to enable optimum utilization of cloud resources, and cloud service should implement a disaster recovery program or plan for stored data that enable information retrieval in unexpected situations. And cloud service providers should provide better resilience and enhanced protection from physical threats. Load balancing and symmetric and asymmetric cryptography algorithm must be implemented for optimum data security in cloud computing. So the best practices for securing a cloud is enforce data protection, backup, and retention. Enforce SLA. Vendors should regularly undergo AICPA SAS 70 Type 2 audit, and verify one's own cloud in public domain blacklist. Enforce legal contracts. Prohibit, prohibit user credential sharing. Implement strong authentication, authorization, and auditing control. Check for data protections. Implement strong generation and monitor the client traffic, and disclose applicable logs and data for customers. Analyze the cloud provider security policies. Ensure physical security is 24/7 and all the days. Leverage strong two-factor authentication. Analyze API. And now we'll talk about SAML. So SAML is security assertion markup language. Security assertion markup language. So the security assertion markup language is a proper open standard protocol used for authentication authorization between communicating parties. So the SAML can be offered as a software as a service and to be installed at a service provider and the identity provider to simplify the federated authorization authentication mechanism for user. So people can use the virtual private cloud, public private subnets, and You can use VPN to connect over the cloud for security. And yeah, those are the solution. And for the Kubernetes vulnerability solution, so for the like vulnerability such as no certificate revocation, ensure the nodes maintain the certificate revocation list. And for the hard-coded credentials path, define a configuration method for credential path and avoid hard-coding credential paths. No non-repudiation, use secondary logging mechanism for processes that require strict and non-repudiation and auditing. So those are the this. And for the like best practices for container security, regularly monitor CVE, employ app aware tools, run as normal users, and like configure application to run as normal user, deploy application firewalls, regularly update the operating system, and configure orchestrations. So those are the like best practices for all. And also employ a zero trust network. So zero trust model is a security implementation that assumes that every user trying to access the network is not a trusted entity by default, and verify every incoming connection before allowing access to the network. So it strictly follows the principle trust no one and validate before providing a cloud service. So the zero trust network is important. So there is one more term, that is CSA, that is International Cloud Security Organization. So CSA is non-profit global organization that provide risking awareness and promotes the best practices in cloud and security policies to help and secure the cloud environment. So this is Cloud Security Alliance, CSA. So it provides education and knowledge on the use of cloud computing, and it helps in securing all other forms of computing. So for shadow cloud asset discovery, you can use Cisco Umbrella. You can also use the like for security tool, cloud security tools. You can use Qualysys Cloud Platform or Federalist Cloud Passage Halo. That is a tool for cloud security tools for protecting your cloud. And for containers, you can use Aqua. For Kubernetes, you can use Kubernetes, Kubebench. This is a tool name, Kubebench. Sorry for the Kubebridge. So it is known as Kubebench. It performs permissions, authentications, and security check across Kubernetes clusters. For serverless application security, you can use CloudGuard. So that is about like solutions for clouds, Kubernetes, and the container technology. Now there is the last topic, that is next generation secure web gateway, NGSWG. So the next generation secure web gateway is cloud-based security solution that protect an organization network from cloud-based threats, malware infections, and theft activities that allow the clients to securely access cloud services. So this is the next generation secure web gateway. So by this we completed our cloud computing. Next up, that is our last module, we learn about cryptography.